Well, I'm back, and now we're doing systematic sampling. There's some randomness to it, but there's also some systematic aspects to the systematic sampling. If you want a sample of size n, you divide the sampling frame into n groups of basically equal size, pick a random starting place in the first group, and then use that same position in each group. So we take the sampling frame as it stands as a list, break it into n pieces of size. Well, you take the sampling frame divided by n, and we'll see how we do it. Here it is. Example. Perform a systematic sample of size 20 from an alphabetic list of 732 people. So first we break the sampling frame into 20 groups. We divide 732 by 20, we get 36.6. So we want groups of around size 36. We just round that down to 36 to make sure we'll be able to, if we rounded it up, we might run out of space at the end. So we round down. So we're willing to not quite put the last few people on the list into the sample. We have to do something though, because we're doing systematic sampling. So we rounded down to 36, pick a random starting place from 1 to 36 using the tables, start there, and then 36 places further down the list, and then 36 more and 36 more. Continue until 20 places have been chosen. Okay, so we're using 36. I'm gonna pick a random starting place. Here it comes. So I'm in the table. I picked a random starting place, which was right here. And then I'm looking from, looking at 0, 1 through 36, because we want to find a random starting place among the 36 individuals in the first block of 36 folks. We find the first number between 1 and 36, that's why I work way down here. I get 15. Get 15 as the start. Okay, and so then the chosen sample is at these positions on the list. Let me back this up. So it'd be 15. And now I'm adding 36. I think I'm adding 36. So the lists are 36 long. So here we go. I've got my calculator here. Can I do this? Yeah, I suppose I can. There we go. Clear this. So I take 15 plus 36. 51 plus 36, 87. I just keep doing that. 123, 159. We're trying to get 20. That's not good. This will take too long. 195. We just keep doing that. So position 15, 51, so that's 1, 2, 3, 4, 5, 6, 7. I guess we just keep going. I can't see it now. I'll come back. 267, 303, 39, 75. Where am I? 411, 447, 483. So there's 7 there. 7 says 14. Here comes 15. 5, 9, 15. 16. 17, 18, 19, 20. So we double check this. So initially we had 732 on the list. The last person is chosen at position 699. And we can't go 36 further because that takes you past the last number on the list. So that kind of makes sense. So you might do this with an alphabetic listing to make sure you get all the last names represented. That tends to guarantee you get all the ethnicities that you might want in your sample. Although it's doing it in a kind of a funny way where you're picking a random starting place and then off you go using that random starting place and moving a fixed number of spaces each time past there. So that is what they call systematic sampling. I am going to put this back so I can see it. Okay, I'm going to go ahead and stop this recording and then we'll go on to the next method. I guess it's going to be called cluster sampling for what I see here. I'm going to stop this recording and start a new one.